Yeah, hi everyone, Mr. Mark here. In today's video, I'm going to show you how to calculate the unknown or an unknown side in a right angled triangle using trigonometry. Today, the two examples I'm going through, the unknown will actually be the denominator. I'll get to that in a minute, but essentially my class, what we looked at last lesson, was calculating an unknown side when that unknown was the numerator. So at the top of the fraction, when we got to this point, when we got to step 3, and basically that meant then to solve it algebraically, we would multiply both sides by that denominator, okay, to solve it. So it'll be a little bit of a different step at the end, but I'll get to that when I get to step 3. The first step I've got here is to draw and label the triangle with H for hypotenuse, O for opposite, and A for adjacent. So I'm going to go ahead and do that now in this first example. I can imagine that I've drawn that right angle triangle in my book, including all the information, the angle, the right angle, and the length and the unknown length. So go ahead and label, starting with the hypotenuse, which is opposite the right angle. Okay, so that's your hypotenuse. Label it with a H. I then like to label the adjacent side next, which is joining the angle of reference and the right angle. So this side here that joins those two angles is our adjacent side, and the side that's opposite the angle of reference, or the last one there, is the opposite side. So step 1 is done. I've drawn it and labelled it. Step 2 is to determine which ratio we're going to use. Now remember the acronym SOHCAHTOA, that helps us determine what ratio to use. So at the moment I've got 3 letters, H, O, and A. I'm only going to use 2 of those. Which 2 am I using? I'm using the H because that's the unknown side that I want to work out. Okay, that's labelled X. I'm using the O because that's the side that's given to me, 21 meters. So I don't actually need to use the adjacent side. I do need to use the opposite and the hypotenuse. And if I go back to my acronym, SOHCAHTOA here, O and H are in that first ratio, the sine ratio. Okay, so that's the ratio that I'm going to be using. Alright, so then go ahead and write that down. Sine theta equals the length of the opposite over the length of the hypotenuse. Step 3 is to go ahead and substitute the values from the diagram into the ratio. So I'm going to basically write the same ratio again. However, instead of the theta symbol, I'm going to use the angle of reference, which is 33 degrees. Just put in 33. You don't need to use the degree symbol here on your calculator because when you're using those ratios, it knows that you're working with a right angle triangle in degrees. Instead of O, I'm going to use the number 21. And instead of H, I'm going to use the variable X. Okay, now at this point, the unknown is the denominator. It's the bottom of the fraction, which is different from, like I said, with my class, what we were doing the other day. The last step was then to multiply both sides by the denominator. So if I did multiply both sides by the denominator, I'd still have x times by sin 33 is equal to 21. So algebraically, that's how I would do it. But then I would also have to isolate x, divide both sides by sine 33. So essentially, the last step, if the unknown is the denominator, is to divide. Alright, so x is now equal to 21 divided by, or 21 over sine 33. Okay, you can write it as a fraction, or you can write divide in your calculator. It doesn't really matter. Look, that's just a shortcut. Algebraically, as I said, you have to multiply both sides by x and then divide both sides by sine 33. But that's just a bit of a shortcut. You're just basically swapping the x and the sine 33 over, as you can see. Right. Then you can just put this onto your calculator. So x is equal to, I'll get my calculator up here. Now, just remember my answer is going to be bigger than 21 because the hypotenuse will always be the longest side in this right angle triangle. So if it's not 21, then I've done something wrong. Also make sure you have that little d on your calculator so you know it's set to degrees. So 21 divided by, or 21 over, it doesn't really matter how you do it. It'll be the same answer hopefully. Sin 33 is equal to 38.557, but I'm going to round to 2 decimal places. That's what it asked for in the question. So I'll look at that third decimal number. Because it's 7, I'm going to round that 5 up to a 6. So 38.56. In this case, the units given is meters. Okay, so that's it. That's how you calculate the unknown side using trigonometry when the unknown is the denominator. I'm just going to run through and do this next one really quickly using the same process. Okay, step 1, draw your triangle. Step 2, label those sides. So H for hypotenuse, A for adjacent, O for opposite. Step 1 done. Then determine what ratio I'm going to use. So in this case, I'm using the adjacent side, which is the unknown side, and the opposite side, which is the given value. So I don't need to use the hypotenuse. Looking at my 3 ratios, the ones that involve the opposite, or the ratio that involves the opposite and the adjacent, is the tan ratio. Okay, so I'll go ahead and write that in. Tan theta equals O over A. Substitute my values into that ratio. So tan, in this case, 53 is equal to 71.3. That's the opposite side, over x. Okay, now next step, solve it algebraically. Basically, we're swapping the left-hand side with the denominator here. So x equals 71.3. Let's just do divided by 10. 53 on the calculator to show you it doesn't matter which way you do it. In this case, 71.3 divided by 10, 53 is equal to 53.73. Again, in this case, my units of measurement centimeters, so make sure you include that. And that's it. All right. So how to calculate the unknown side using trigonometry when the unknown is the denominator. Hope that helps, guys. Thanks for watching.